RC circuit. RC circuit is a special kind of circuit that consists of resistors and capacitors, like the one shown here. In this particular case, it only has one R and one C in series with each other. Now, they are also called RC filters or RC networks. RC circuits have many advantages. Some of them I will talk about here include windshield wipers. When they are set at intermittent setting, the charging of a capacitor to a certain voltage is a trigger that turns them on. The time delay is determined by R and C in the circuit. The variable R is used to change the length of the time delay. Pacemakers and strobe light time delays are also controlled by RC circuits. So how do RC circuits work? Well, they work by charging and discharging the capacitor. Using calculus, it can be shown that the voltage across the capacitor is given by V equals EMF 1 minus E minus T over RC, where E equals 2.718 is the base of the natural log, and the quantity RC is called the time constant for the circuit. Similarly, using calculus, we can show that the current for the RC circuit is given by I equals EMF over R, e to the power 1 minus RC. Luckily for us, this is the algebra-based class, and we will not actually be deriving these formulas. You just have to know them in order to solve the problem. So time constant is the product of the capacitor of the capacitance, the capacitance of the capacitor being charged, and the resistor inside the charging circuit. Tau is also the way we write it. Tau equals RC. The unit of tau is seconds. And we can show that by solving for this. So C is given as Q over V, and R is given as V over I, and I know I is equals to Q over T. So if you solve them, you are left with T, which is the unit of time. So when a capacitor is charged, V, the voltage, is given by epsilon 1 minus E to the minus T over RC. What does that mean? Initial current is 0, and as you keep charging the capacitor higher and higher, the final current becomes really, really large. Exponentially increasing graph, so the voltage will go from 0 to maximum voltage of the capacitor. The charging factor depends on the capacitance and the resistance. Discharging capacitor, the Q will equal Q e to the minus T over tau. I will be minus epsilon over R e to the minus T over tau. So current flow initially when the capacitor is being discharged is very high, and it will flow opposite to that of the charging capacitor. Finally, it will approach 0. It will be an exponentially decreasing graph, and the discharging factors include the values of capacitances and resistance. So the graph will look something like this. Now let's do an example. Two 5 microfarad capacitors are in series, are connected with a 50 volt batteries through 4 mega ohm resistor at t equals 0. The capacitors are initially uncharged. Find the charge on the capacitor at t equals 0, t equals 1, and t equals 3 seconds. Find the current in the circuit at the same 2 times. So first off, I am going to draw the circuit. It says it has 50 volts EMF connected with a 4 mega ohm resistor. 4 mega ohm resistor, and it is connected to 0.5 and 0.5 microfarad capacitors. So these capacitors are connected in series with each other. So I have to find the C equivalent for this scenario. So for capacitors, the C equivalent will be equals to 1 over C1 plus 1 over C2. This means 1 over C equivalent will be equals to 0.5 plus 0.5 microfarads, right? And I can solve this, so this will be 1 over microfarad for now. Solve this to calculate C equivalent equals to 0.25 microfarad. Okay? The other thing that I know I'm going to need is the time constant. So how do I find the time constant? Time constant was equals to RC. So in this case, my R is 4 mega ohms, so I can put that in. 4 mega means 10 to the 6 ohms, time C equivalent, which is 0.25 micro ohms, so it'll be 0.25 times 10 to the minus 6. My time constant value comes out to be 1 second. Ooh, that's significant. That's good. So now let's start actually doing the problem. So part 1, what it says is, find the charge on the capacitor. So I need to find Q, C, at t equals 1 and at t equals 3 seconds. So at t equals 0, the charge on the capacitor obviously will be 0. How do I find this? I know that the charge on the capacitor at any time will be given by C equivalent Vc of t. Okay? Which means this will be C equivalent 1 minus E minus T over RC, or time constant. Yay! This is equals to Q total 1 minus E minus T over tau. What is Q total? Okay, Q total is nothing other than C equivalent epsilon, which means this is going to be 0.25 microfarad times E, which was given as 50 volts. So Q is nothing other than 112.5 times 10 to the minus 6 coulomb. So I take that value, I plug it in. So this is my time constant, Tc or T, and I can calculate it at any given time. So at T equals 1 second, Q will actually be equals to 7.9 microcoulomb. I'm not actually going to be plugging in values. And at T equals 3 seconds, Q will equal 11.9 microcoulomb. Now, what about current? Next it asks me about current. So I need to find current at both of these times. How do I find current? I know current is equals to I0 E minus T over RC. What is I0? I0 is E over R, E minus T over RC. What is E? 50. What is R? That value right there. And now all I have to do is plug in the numbers, and I should be all set. So, given that E is equals to 50, R equals 4 mega ohms, tau or RC equals 1 second. Can you calculate I at t equals 1 second? And the answer is absolutely. I at t equals 1 second can be calculated, and my answer is 4.6 microamps. And I at 3 seconds, I calculated to be 0.622 microamps.